Hello, everybody. Good morning, good afternoon, good evening, depending on what time you are listening to my lecture. So, welcome to my lecture on overview of business analytics, provided to you under this initiative or this partnership of Ashland University MBA program and Ohio X. So my name is Nitin Walia. So let me give you a brief introduction of myself. Hello again. Uh, I joined Ashland University in 2010, and currently I'm associate professor in the MIS department, and I'm also program lead for business analytics degree programs at both MBA and undergraduate level. Uh, Before joining Ashland University, I finished my PhD from University of Wisconsin, Milwaukee. And prior to that, I completed my master's from Oakland University in Michigan. And I also have another master's and bachelor's in business from India. That's my academic background. Professionally, I have worked as an IT analyst at 3M and programmer at Baytalkie Tech Limited. As you can see, most of my research as well as my teaching nowadays is in area of analytics, business analytics, data mining, data visualization. I feel quite passionately about these fields. I have done multiple trainings over last few years in these areas, and I just love teaching and talking about these subjects, which I'm gonna do right now. Okay, so that was my background. So let's get started with the topic, business analytics. So this presentation is intended for somebody who is thinking to maybe start a degree in business analytics, maybe an MBA, join MBA program for that, or maybe you at your workplace are thinking to start using analytics tool for various business problems, or trying to incorporate these tools for your business. So my goal is to give you a starting point for this area, and I would love to talk to you later. You can get in touch with me or come to my classroom under our MBA program, and where we go in much more detail and much more detail in these topics. Okay, so with that said, let's get started. So business analytics, it's one of the hottest topics field in last 5-10 years. So the question you might ask is this something new which we just started a decade back? What were we doing before that? And that question I'm going to answer on my next slide. And in this presentation, I'll be talking about the three categories under business analytics, which is descriptive, predictive, and prescriptive. And these three categories are somewhat sequential as you approach a problem, and I'll be talking quite in detail about these three areas in my presentation. Before we get into this, I also wanted to address sort of the difference, or my take, my understanding of difference between a business analytic or a data analytic person versus a data scientist. So in our program, especially from an MBA viewpoint, we train students, or our goal is to teach our student from a viewpoint of business analytics, where you are using these tools in a much more applied manner to solve a business problem. So you're a manager, or you are trying to solve a business problem using some of these tools. On the other hand, data scientists, at least in my understanding, would imply that you would have a little bit more deeper understanding and knowledge of statistics, as well as understanding or exposure of programming languages and statistical tools like R and my favorite language, Python. So there is a little bit a difference between these two areas. Okay. So let's start with analytics. First of all these three areas, analytics, business analytics, or business intelligence, all these fall under business analytics. The domain is business analytics, which is again changing towards machine learning and artificial intelligence. But let's for now just limit ourselves to these three areas. So this area is still evolving. So what my understanding or what my definitions here are, they might change, or I would say evolve over the next 1 or 2 years, especially as we make more strides in the area of artificial intelligence and machine learning. With that said, I would say analytics is coming from, or is very strongly based in its foundation, is based in statistical techniques, analysis, operation research methodologies. And its goal is to examine and investigate data so that we can visualize, explore the underlying data. The jumping all the way to the bottom, business intelligence. Business intelligence field is, its goal is to collect data and then store it in a logical manner so that we can access the data at a later point for reporting, for some query, or to do some reporting purposes. So with that said, business analytics, which sits on top of both these fields, includes both analytics and business intelligence. But in addition to that, we use the fields of or categories of descriptive, predictive, and prescriptive analytics to support business decision making. So that's a very key word there, that the purpose of business analytics, as the name implies, we have added the word business there. The purpose of there is to apply all these techniques in a business domain to solve a business problem, or to aid a decision maker in making a decision. So the goal or the focus is much more on the business side. The goal is much more to implement these techniques to achieve a result. So what I meant by implement a result is like going beyond statistics, where you do data analysis. You said this variables are significant for an independent variable, or for the dependent variable. Sorry, but what does it mean for us in a business? So in business, we use business analytics to see what might be our sales for next quarter, or how much customers we might lose during a holiday season, or what trends, what products go well together, or we can sell them together, or how can I best optimize my warehouse or my raw materials. So the goal is whether through data mining, through predictive model, through prescriptive model, or through these amazing charts which we make through visualization tools, to get us insight and understanding of data, which we can use towards solving business problems. Okay. So now putting it all together, the three categories of business analytics, which are somewhat sequential as well when you approach a business analytics problem, starting with descriptive analytics, then predictive and prescriptive. So under descriptive analytics, we looked at the past, or at the past or at the present. What has already happened, or what is happening, and at this point of the time you are basically exploring your data. What data do you have? What kind of questions you can ask and answer, and you're trying to understand your data. Followed by predictive analytics, which, as the name implies that you are predicting something, that what will happen. And one of the main what we use is data mining to do that. And then the last step is prescriptive analytics, where after we had made a prediction, if we want to say how can I achieve a certain goal, or how I can do something to achieve my goal of sales or my revenues, for example. And it is mainly you do your optimization or simulation. An example of that would be, I have this warehouse. What would be the best way to store my products or materials in this room, given the area available to me, or how to maximize my profit. So all these areas fall under business analytics, and that's what we are going to talk about in this presentation, starting first with descriptive analytics, where we start first with talking about what kind of data we have, where we are getting that data, followed by data warehouse, from where you pull your data to run SQL queries, to do data reporting, as well as data visualizations. So to do any kind of analysis, our first starting point is always the data, and that's where we need to understand various aspects, the various facets of data. The first could be data format, or where's the data coming from? Are we manually entering the data, which is rare? Is it coming from a text file, a Excel spreadsheet, a relational database, maybe an ERP system, or this large, huge data dump sent over an XML file? Then data sources, where we talk about, are we getting a data from some survey? Are we collecting it from some social media? Is it a retail data, which we are getting from a vendor? And most importantly, what we have to understand in data sources, is it self-reported versus actual data? And that affects how we do data analysis using that data. Categories of data would again mean, it's a demographic data, is it behavioral data, or is it attitudinal data, where people are giving their opinion, or they're doing their survey. So these are some of the things which we get into in our classes as a starting point for our project, that before we can do any kind of analysis, we should have understanding of the data itself, and if there are any issues with data, like missing data, or if we have some noise in the data, we can clean it, we can prepare our data before we get into using any tool. So that's always, understanding the data is always the starting point for any research project. And of course, understanding the domain of the data, or business understanding of the data as well. Then once we have the data available to us, we have cleaned it, the next step, which I try to teach my students, or we do it in a project, is data visualization, which is visually representing your data not to do any statistical analysis, not to do data mining or anything like that, but to exploring your data, to discover, find some insight in your data, because it's always easy to find insight in your data through creating a chart than looking at raw numbers or tables. So the main goal of data visualization is understanding your data rather than doing some sort of data mining or statistical analysis. And data visualization is a field which I really, really love. One of the tools which I really love is Tableau, used for data visualization, which we use quite heavily in our classes as well. And the first rule of data visualization is that before you can do any charts, any data visualization, if something you can present with a simple text, don't make a chart of it. So for example, if I made a bar chart showing all the score of students in my class, what categories they fall into, versus a simple text slide, average score for my MBA class is 94%. So if you can do something with a simple text, don't create data visualization or chart for it. The next one, this one is a slide created by one of my students for their presentation this semester itself, where they did this presentation of data related to coronavirus. This was sometime late April, so that data is from there. So before they created pretty cool visualizations of various cases by state, by countries, and things like that. Their first, you can say, their first presentation was this big number, this text, rather than a visualization, which is much more impactful, I would say. Okay. So then coming back to our visualization, these are some of the charts or graphs which I asked my students to use to both understand the data as well as at a later point to present your data. So it works both ways. So these are some of the examples of the chart which we create in a class using various visualization tools. So some of the charts like tree map, symbol map, lollipop chart, heat map. These are some of my favorite charts which we try to create to represent data which has multiple dimensions. And then we also go through how can we use color, which fall under pre-attentive attributes, size, color, orientation, texture, as how we can use all these attributes to better represent our data or make our charts much more meaningful and, more importantly, easy to understand, especially when we have multiple dimensions, multiple variables which we have to present in our data for our presentation for our data set. This I'm just showing it to you for just for your information. I'm not going to spend much time here. This is a white paper done by Tableau where they show the 5 most influential data visualization of all time, and you'll be surprised most of these visualizations were created somewhat in 18th century. March on Moscow by Napoleon, War Mortality by Florence Nightingale, Chart of Biography, London Cholera Map by Jon Snow, of course not from Game of Thrones though. So except the Gapminder, which was created by Rosling in 2007, which he showed in his TED Talk, all these visualizations are 200 years old. And I would ask you, if you have time, check out this white paper. It's available for free. You will really like going through it. It's a pretty easy read and pretty interesting. The next thing I want to talk is, which I show in my classroom to my students, is that charts have opinion. There's a purpose to a chart, and this is one of the chart which makes that point very strongly. So without getting into politics or anything like that, So this chart is from which has a very strong opinion about it. It represents sort of the death rate during the Iraq war, and it's using the color red, and it's, instead of being a normal upside bar chart, it's upside down, it's down, and it gives you a visualization of blood dripping. So it's a very powerful chart, and this chart won the silver medal in one of the infographic awards in 2012. So as you can see, this chart, with the way it's drawn, the use of color, the use of title, makes a very strong impact. Now the same chart, if we turn it upside down, and instead of using red, we use blue color, the chart meaning changes completely. Now we can see that actually the things are improving. The death rate is on decline. So by that, you can see that the way we use color, the title, the orientation of the chart has a lot of impact on how we understand that data. And the key thing to understand is that none of these charts are lying or anything like that. They are both presenting the data in a factual, correct manner. So just wanted to show you that how color, heading, and orientation of a chart has a big impact on the audience. Again, I wanted to show you a catalog of charts. Again, just to emphasize, I'm not promoting Tableau. I just use that tool. I like this tool. There are many other tools out there, so I'm not endorsing or trying to promote any one tool or company here. So this, I really like this resource, Tableau chart catalog, where they have shown so many kind of charts, and I love this Cleveland dot plot. So many different charts available, and it's sometimes it's just fun to look at them and see if we can use one of them to present our data or our presentation. Again, as I said, I'm not endorsing any one tool per se, but I use Tableau, so I just wanted to show you that Tableau provide a lot of their resources for free nowadays. I think their Tableau desktop version is like $30 per month, and I get Tableau for free for my students, where they get the license for 1 year for free. And the good thing is that they can, if they're doing their internship or they're working at someplace, they can use their academic license or their academic Tableau for their work as well. So it's allowed. And I'm sure other companies like Power BI and all those, they might be allowing the same thing. To show you this business intelligence Gartner Magic Quadrant. Gartner, this Magic Quadrant is one of the best known in industry for various tools. As you can see, when it comes to BI, which is mainly data visualization or reporting of data, Microsoft BI and Tableau are sort of the market leaders, which of course Microsoft BI is ahead of Tableau. So these two are much more ahead of all the other tools available in the market. I would say one of the reasons Microsoft has really gone ahead from Tableau is because it's Microsoft tool, so it's quite well integrated. Microsoft Power BI is much more well integrated with Excel and PowerPoint, so that integration helps quite a lot when you are using all these other softwares as well. Okay, so that was my take on descriptive analytics, where you are trying to understand your data, and besides some of this data visualization, you do things like various things like mean, mode, median, trying to understand outliers in your data and clean your data, try to see the distribution of your data. So all that is done under descriptive analytics as well. So moving from that, next one is predictive analytics, where the main thing you do is data mining. So what is data mining? The purpose of data mining would be to find novel, potentially useful patterns in your database or in your data. Some of these patterns could be people like to buy egg and bread together, or people in certain age group, what do they like to buy, or if somebody applies for a credit card, should we approve them or not, or if somebody applies for a car auto insurance, how much would be their potential premium. So all those are fall under predictive modeling or data mining. And data mining has multiple different names. It's a pretty large field. Some companies, they call it knowledge extraction, because that's what you're doing. You're extracting knowledge from it, knowledge discovery, pattern analysis, and things like that. So the key thing to remember about data mining is that this field of data mining builds upon or borrows or builds upon from many other disciplines. Of course, all these have their roots in statistics, mathematical modeling, information system, where the goal of information system is to get the data and convert that data into meaningful information, databases from where we are getting this clean, structured, logical data, machine learning and artificial intelligence, where we are trying to use these data mining tools to automate a business process, or to sort of fasten a decision-making process. So data mining encompasses all these different disciplines and area, and depending on what your interest is or what your organization is doing, you might be more heavy on one of these other disciplines, depending on the business domain you are in or what kind of job you want to do. These are the examples of some of the data mining algorithms which we teach in our classes. I go through decision trees, neural networks. We do k-means, regression, of course. So these are some of the popular algorithms, supervised and unsupervised, which we cover in our classes using SAS, Enterprise, minor tools. So decision trees and neural networks, I would say, are one of the most popular supervised learning methods. That's what you should have some understanding of these algorithms to use data mining. But again, the key thing to remember is that using these tools, we already have, using these algorithms, we already have tools to do that. SAS Enterprise Miner, SPSS, or SAP HANA. So we use those tools to run these algorithms. Our more emphasis or goal is that once you have run these algorithms, how do you understand or interpret the results or apply those results to your business domain? So our goal as a business analyst, analytics person, is not to go too much into the background as how a certain algorithm is running. Our goal is more to understand the results and apply it to our business domain or business problem. So let's look at some of the application. So CRM, or customer relationship management, it's one of the very big user of data mining applications. You can use data mining to identify who are your most valuable customers. They say generally 80% of the business comes from 20% of your clients or your customers. Maybe you want to treat them better. Maybe you want to give them a better uh, customer service, a direct phone number, give them upgrades like how airlines does. You can use CRM or data mining, sorry, to see why do our customers leave us? What are some of the key issues? Or maybe is Christmas is a time when most of our customer leave us, like for some of the telephone companies, AT&T, Verizon. What can we do during the month of December that the customers don't leave us, so we can reduce our attrition rate? Uh, Banking, financial industries are one of the biggest user of data mining. So, for example, when you apply for a credit card or even an auto loan, I know there's for auto loan and home loan, there's the agent involved, but still most of the process, and especially for a credit card, when you apply for credit card, the whole process is automated. You apply for a credit card, within 25 seconds you get a result, yes or no, this is your credit line. There's nobody sitting there doing the work so quickly. It's all automated process using data mining algorithms. And then very important, this category, detecting fraud transactions. Every time we swipe our credit card, our bank, Visa, MasterCard, Discover, Amex, whichever you are using, PayPal, they run that transaction to see whether it's a fraudulent transaction. And the key thing to remember there is that once you swipe your credit card, they have like less than 5 seconds to make a call to approve or cancel your transaction. So that further adds to the complexity to it. Then during the last recession, it was a big thing that how much cash reserve each bank should have. So again, data mining played a part in that. Retailing, logistics, which is now going to be a very big part of this 2020 with coronavirus, that how do we optimize our inventory levels. As we saw in last 3 months, most of the stores were some of just ran out of certain products. So how can we optimize our inventory level? That's going to be a very big field, very big usage of data mining algorithms going forward in next 6 months. Most of the companies, especially retailing companies, Costco, Walmart, some other Target, they are going to look at how much inventory they should carry locally as well as their national headquarters or their warehouses, and data mining is going to play a big part of that. Then the other thing, especially for predictive modeling, I want to very much emphasize on is that when you do this data mining process, your 85% of the time, your 85% of your time goes in the first 3 steps. And what are those first 3 steps? Your first 3 steps are understanding the business, then understanding the data, and then data preparation, which is cleaning the data. so which includes understanding of domain, business domain. So for example, before you can do any data mining project, let's say for a retailing company or a financial or a credit card company, you should have an understanding of that business. And that's where having an MBA helps, because you understand the language of business. So business understanding followed by the understanding of the data which has been provided to you, and then data preparation, which takes sometimes a lot of time, because whenever we get a data set, it's never clean, or we have to modify it, add more columns to it. So those 3 steps takes 70 to 85% of your time. Running an algorithm, testing it and deploying it, it hardly takes any time. But again, after you have done these 6 steps, then again the bigger part is then to use those results, interpret those results, and apply them to your business question. Some of the top tools you can use for data mining, commercial tools. The top tools are SAS, SAP HANA, Statistica, SPSS. These are the top commercial tools. I think SAS is the biggest one, has the most market share. Commercial tools. In free and open source products, Python and R are the biggest competitor. I think with SAS, Python, and R, they have nearly 70%, 75% of the market share. And if somebody, a student or somebody who wants to get in this area, they should have understanding of or skill set in either SAS, Python, or R, one of these, in addition to having understanding of SQL, which was part of descriptive analytics, and some data visualization tool like Power BI or Tableau. Then the last thing we are going to talk about is prescriptive analytics, which, as the name implies, you have made a prediction. Let's say your prediction is 8% profit your company will make in next quarter. How can we change that? What can we do better to maximize our profit? That's where you're prescriptive. Getting a prescription, a medicine to make your profit better comes into play. But it's most of its usage are in optimization and simulation areas. Optimizing your profit, optimizing your use of your workforce, optimizing your use of your storage capacity, inventory, things like that. So that's what we do in prescriptive analytics. Maximization of profit, optimal spending, things like that. And one of the tools which we use to learn optimization and simulation is Microsoft Excel. Microsoft Spreadsheet. Excel is still one of the best tools to learn it. So if you want to do optimization, you should have understanding of skill sets and running what-if analysis, goal seeking, and solver, and all these are available for free under Microsoft Excel. So to sort of sum it up, descriptive analytics is what has happened, and we want to understand what has happened. Predictive analytics, what might happen, and prescriptive analytics, what can we do to change what might happen. And I think this might be a good time to say that all the graphics which you have seen in my presentation, my presentation itself is based on multiple books and other people's presentation which I've attended. So I have, as in academia, I learn from other people and I use them. So if I have some reference missing for any of my pictures, I apologize for that. If I've borrowed it from somebody and I missed their reference, I'm sorry for that. Finally, I would end with this example, which you can consider it as an urban myth as well, which I hear in every analytics conference I go to. So there's this example that a retailer in England, I think, did this study that young men, because in England you can start drinking at the age of 18, so young man, age of 18 to 34, on weekends from a retail store, they were buying beer and diapers together. So it's kind of a weird association of these two products, beer and diaper, together. So what that tells retailers is maybe place these two items next to each other, or maybe run some sort of promotion on one of those items to get those young men in to get beer, and then they will buy diapers as well. And one of the reason I would say this urban myth might be true is that young men who have higher likelihood of having a young child would be staying home, because you have a young child. You cannot go to a bar or a club, and then if you're staying home, it's Friday, Saturday, you still want to relax, so you might you cannot just go and have scotch or rum, so you'll have something lighter like beer to relax at home, and while you're still in your senses, to take care of your child. The study did analysis of young men, but I'm sure it could apply to young men and young women as well. Then finally, to give you an overview of this ecosystem, I would say for somebody trying to get into this area, doing a degree, whether MBA or master's, MS program, or an undergraduate in analytics make a lot of sense, a lot of jobs. And what we try to do in our program is that we expose you to all these different areas so as to equip you with enough skills that then if you desire, you can go and do much more specialization using some of these online certifications available to you, which we show our students as well. Some of those online certification could be through SAS, Tableau, Power BI, things like that. So you get enough foundation and skill set from our courses that you can in future do some of this much more specializations yourself based on what you have learned in these courses. Finally, I would end with, I know I've gone a little bit above the time I wanted to. So these are two good resources where Cleveland Clinic partnered with SAS to come up with various COVID-19 prediction models. They also built various analytics tools to track, treat, and stop the spread of COVID-19. So this is a very interesting case study. I provided you both these links, or if you Google search, you will find it. So if you have time, Cleveland Clinic is one of our local companies, and this shows you how in this era of coronavirus, COVID-19, how they're working or how they're using analytics for this healthcare, for this pandemic, for this healthcare situation going on right now. I would end with the contact information for our MBA program director, which is Ron Mickler, and I'm providing you my phone number as well as my email ID as well. Please feel free to get in touch with me for any questions, or if you want to go in more detail, you want to just talk to me on phone, discuss something, ask me any question, email me. I would happy to talk to you or answer any of your email regarding anything I talked today or anything else about this area. We'll be happy to talk to. And then you also have, I'm also providing contact information of our MBA director, if in case you are interested in pursuing a degree in analytics at MBA or at undergraduate level. I again want to thank you to listen to my presentation. So thank you for your time. I hope you're remaining safe and healthy and taking care of yourself during this And again, I want to thank you for your time, and again want to repeat that a lot of graphics, pictures, or even some of these areas is based on tools provided to me by SAS, by Tableau, which I try to integrate in my classroom. So if certain reference is missing, which is a very big deal for me in academia, we always like to cite other people's work. So if something is missing, I apologize for that.